Hello all, welcome to another session with me, Varun at Odin School. So talking about Odin School, we at Odin School, we are a technology upskilling platform and we would help you continuously acquire new skills, thereby you could stay skilled and stay ahead. And my name is Varun. I have an experience of 7 years and I've been working as a developer and a trainer over these years. And I have, during this tenure gained knowledge on HTML, CSS, JavaScript, and some other platforms like or some other languages like Python and concepts like machine learning and etc. So this is all thanks to the different organizations and the different projects that I've been able to work with. Now going forward, the agenda of this session would be to understand what is data cleaning. All right. The second one would be why is it important and the methods to do it. So here, when we talk about it, we would be splitting this session in two parts, wherein in the first part, we would be understanding what is data cleaning, what are the different types of data cleaning and how do we handle them. And then we would be moving on to, after 1A, we would be moving on to 1B, wherein we would be talking about why it is important and what are the different methods to do it. And then we will be moving on to the second one, which is supervised versus unsupervised learning. Alright, so now going forward, this would be the agenda, and talking about supervised and unsupervised, we'll have a look at what are the different supervised and unsupervised models and how are they different from each other. Alright, and let us now go forward and understand. Now as you can see here, let me just use a data in machine learning, in fact, forget machine learning, data in any language or in any paradigm or any platform is considered to be of primordial importance. And here we use different methods to collect and to store and to analyze the data. But this data that we use here, it needs to be cleaned and it needs to be organized before you actually apply any machine learning algorithm to it. Now, when we talk about workflow of how we work on, or what is the stage that we work on data cleaning, it is generally organized into 4 to 5 segments, wherein in the first segment you gather the data, right? Then you understand, and from here, once you have gathered information into your data, you start cleaning your data. Now this data cleaning consists of a lot of processes wherein you would be having to remove columns or probably add columns or probably handle missing values. Now there are different methods to handle missing values as well, and or probably you could want to replace the values, or you might want to impute. So there are a lot of things. You have standardization, you have normalization. So all these are different processes that we apply onto any data set before you actually start working on it. All right, and one of the biggest challenges, or as we all know, step one towards any project or towards any machine learning engineer or any data analyst would be to clean your data. So data cleaning, in fact, is the first and the most important topic that you all should be covering in the field of data science. And why is it important? Because until unless you convert your unstructured and your unclean data to structured and clean, it will become very difficult for you to work on any kind of operations further. It could be any kind of operation. It would actually become very challenging for us. Now, in this case, without proper cleaning, you would see that 2 to 3 cases is something that we very frequently come across. The first one is you would be having a biased result, or your result would be totally wrong, or you would be having an error or probably no result, or rather you would get stuck somewhere in between while you're coding. Right, so these are the 3 cases that would happen, and any of these, they are always called as inconsistencies in your data set, and this is something that you would not expect when you're working on any project. right? So that is the most important reason why it is very essential for us to ensure that your data set is properly cleaned. And it could be any kind of an algorithm that you're applying, even if it is a very complex algorithm like a deep learning one, or a basic one like a machine learning, or yet more basic like an ANOVA, which is to do more with statistics. Even in that case, a basic cleaning or a basic understanding of your data set is essential and is very much required. Now, when we talk about cleaning your data set, as said, there are different methods to handle this phenomenon. And of these, the first one is to understand what is the processing steps in pre-processing. So that is something that I will be talking about right now, and then we'll be moving on into the part of it. So here, as we know, once you have your data set with you, guys, this is your data set. Okay, it's not data science. Then you import your libraries. Okay, after which you will be handling your missing values. Now there are different methods to handle missing values. You can either replace them, or you could use imputation methods wherein you can impute them with the mean or median or the most frequent kind of a command, and any of these three would be giving you the same, or would be yielding the same result. Or now when I mean to say they would be yielding the same result, we would be using each of these in different cases, but yes, they all would be working, or they will be working towards the same thing. Then the next thing is you would be dividing, once you have handled, or once you've worked on basic things, you would be dividing your data set into independent and dependent columns. I'm just trying to give you a workflow here, a workflow of how we work in the field of data cleaning. And now that we've done a lot of hands-on in this session, let us let us just go through a visual treat. Let us just sit back, relax, and understand what is it that we've done in all these sessions, and how is data cleaning important, and what is the difference between supervised and unsupervised machine learning algorithms. Right. So yeah, we will be dividing your data. So this is step 1, this is step 2, this will be your step 3. Your step 4 is wherein you will be dealing with categorical values. In your step 5, categorical values, if in case you have any. Then you would be splitting, after your categorical values, if you still have any other things to handle, like outliers which have to be treated. Okay, outlier treatment is very important for us. And then you would be splitting your data set into test and train. Whenever you split your data set into test and train, we all know that in majority of the cases, we would be ensuring that your train has 70% of the data while your test has 30, or anything less than that. We ensure that this is not going below 70 or below 65 to 70 if taken a range. Alright, because we want to ensure that your train set has the highest quantity of data available for a lot of learning to happen, and then based on what it has learned from your training data set, it would apply the same on the testing, and it would check. And please remember this process, because this process, or difference in this process, happens to be the underlying principle between supervised and unsupervised learning. The next one we would be working on would be feature scaling. Alright, so these are the different processes or different steps that we have when you're working on a data set. Now, when you check for null values, we all know how to check for null values. If you're working on Python, then it is very simple. You have info, and if you are working on R, you can directly check it using summary, or you can, you have a lot of ways to check for your missing values, or there are a lot of methods to check for your missing values, or there are a lot of methods available to check. Now, talking about data cleaning and what are the different processes involved here. The first one, let us just consider a small example about how your data set would look like before cleaning and after cleaning. So here, if I consider I have a small graph wherein the inclination you can see, and here I would be considering a couple of random vectors or random data points. Now, if this is my graph wherein it is not corrected, alright, or uncleaned, then you can see that when I move on into my other platform, right, and when I come up with a plot, you would be seeing that after cleaning it will be more sorted. Right, everything is more neatly arranged and you have data which is more clean and more understood and more aligned. So these are some basic differences when you work. Now, when you have values which are not required, you might want to remove a column in total. All right. Now, removing is not the only option, but still, in a lot of cases, we do that. Now, when you have missing values or missing data also, then we have three options, or there are three things that we could do to it. The first one would be you leave it the way it is, or you fill those missing values, or using imputation method, or you drop them. Alright, so these are the three options that you have when you're working on NN values. Then the next one that you have is handling outliers. Alright, and we all know what outliers are. Outliers is any data which is too far from your general range. Okay, and what is outlier? It's a data point which is way different, or which is very far off from your general observation. So here, let us consider I have scores of Indian cricket team wherein you have around 8 batsmen who have performed out on the field, and their scores are 20, 31, 18, 42, 95, 87, and again 24 and 19. Now, in this case, it's very clearly understood that these two are the outliers here, and probably this can be considered as your maximum extent, and 18 can be considered as your minimum extent. And things like these can be visualized beautifully when you're using a box plot. And then we all know what's a box plot. We've seen a practical implementation of box plot in one of our sessions. Right, so this is box plot. Right, guys? So I hope you have understood. Now, also there are different other methods or other ways to ensure that we detect outliers, and of them, one of the very famous method excluding box plot would be a scatter plot, wherein you have a random set of points, and based on this you can understand if there's any point which is way too far. We also have z-score or z-score as they call it. You have z-score, which is also a very important way, or a very widely used way to understand. And then after this, once we are done with the most basic kinds of working, there is next another very important conversion which we fail to do, or which we forget to do, or which we fail to talk about in most of the cases, and this would be to ensure that you work on your data types. Right, now when you're working on data types, there are different types of data types which we use. I would firstly start with numeric or integer type. Okay. The second one would be your categorical. Okay, and finally, the third one would be your Boolean values. Okay, these are the three very widely used data types we have, and here whenever we use these data types, it is very important for us to understand them. All right. And guys, please remember, if you have any queries, please use the comment section below. As me or my team, we will be getting back to you at the earliest. And also, if in case there's anything that you feel that you should note down, please pause the video and make a note of it, because it's very important for us to understand these, because when you go to an interview, these are the very basic questions, or these are the most simple things that you will be questioned on. All right. So yeah, so these are the basic conversions that you will have to know. All right, and these conversions which we work on are very important for us. All right, and if you're talking about R or Python, then there it's very easy for us to convert them. All right. Then the next one we have is also text conversion. Now, all the while we were talking about numbers, but even when we talk about simple information, it is important, right? Okay. So this is the thing. So now the most important takeaway here is, as long as you're working on data cleaning, guys, it is imperative that you ensure that your model is error-free. All right, and how would you make it error-free? In order to make it error-free, you have to ensure that all this process which we have, all these steps which we were talking about, they have to be followed. Okay, now let us go forward with the discussion. And even when you talk about textual cleaning, even there you would be having a lot of steps. For example, when you talk about NLP, right? Even in NLP, when you're working on text, right, you would have to firstly work on capitalization. And after capitalization, you might have to remove the special symbols. Alright, after you remove the special symbols, you might also have to ensure that there are no expressions or there are no there's nothing else except information, like information between A to Z, and the whole information between A to Z has to be only in small. We'll look at a small example on our platform today, though there's no need for you to get your hands dirty or probably move out of your comfort zone. You can just lay back and listen, but still this is something that you might prefer practicing when you have ample time. Alright, so now let us go forward and understand this phenomenon in our language, what I'm trying to talk about. And now that we've worked on a lot of basic level data sets which have numbers or which have values, in this data set or in this specific case study, let us work on a small text analytics example. Alright, and here, as you are able to see, I'm considering a small data set, and this data set is a span data set. And here, let's just take a look at what all I am doing. So in step 1, as you are able to see, I'm converting this to my lower case. So all my content, all my textual information will now move from or will now get transformed from capital casing to lower casing. Then in my next step, I would remove punctuation marks. Alright, and when I remove punctuation marks, full stop, commas, or probably quotes, or all of these would get eliminated. Then in my third step, I would be using remove numbers, and when I use remove numbers, any kind of a short form which we express nowadays, like before is very commonly expressed nowadays like before. Before is expressed as before. Now before actually makes sense here, because there might be a lot of textual lingo like this which we would not want to consider, because when you're working on information like this, your system would consider a standard dictionary. All right. So it becomes imperative for us to remove numbers or anything which does not make sense to English. Then you would strip white spaces, that is all those spaces which are not necessary, or double spaces are all eliminated. And then in my next step, I am finally coming up with a plot which is stop words, and this would ensure that I have my small graph with regards to each text, like showing the importance of which text has what. And then I'm using my word cloud too, and even before that I'm checking my frequency. And also guys, all these steps which I am trying to come up with here, to read the data, or then to transform my data into a different phase from, or change the original data set into a required phase. All this is happening because it is very important for us to do it, without which you would not be able to see the end result in it. Alright, so that is where things like these make a difference. So now let us again go back to understanding what is the meaning of each of these, because I think if you know these, then I think you would be good to say that you have a sound understanding on what is cleaning your data set. Alright, so here you have missing data, you have noisy data, and you have inconsistent data, right? So when you talk about missing data, you can do either any of these three. You can ignore the data set, you can fill them manually, or you can fill computed values. Then the next one you have is noisy data. Here also in noisy data set you could use binning, or you could use clustering, or you could find it in machine learning algorithms, or you can remove them manually. And then in the third case, you have your inconsistent data. And inconsistent data would generally be handled, I have written a couple of points here, like external references and knowledge engineering tools. Now this is something that we would see as we go further. So notwithstanding, these are some steps that you could use in any of these, in any of the languages. So let me just siphon this off using R as well. Alright, so you have rescaling, which we do. You have standardization, you have normalization, you have binarizing data, you remove the means, you have one-hot encoding, and you have label encoding. All of these processes are very important. Let us just talk about one or two for an example. A lot of times we see that when you're working on your data set, you have a column salary and age. You notice that the salary is 19,000 and the age is 20, or probably the salary is 35,000 and the age is 21 or 31, whatever. Even if you consider it that way, we notice that it is not 10 times, it is not 20 times, it is almost around 100 times different to the value in your salary. Alright, so this is happening because of now when you look at this, if we try to come up with a plot, we would be seeing that there is a very huge difference between these values. And in order to bridge the difference, you would be using one of these processes. And then the next one that we have is let us assume that you're working on a column, alright, and this column has three features like London, or probably like San Francisco, US, and probably Canada. Now here you can see, okay, let's take this as Las Vegas. Okay, so you have San Francisco, Las Vegas, and Canada. All of these are part of USA. So here now, when I work on these, it would be easy for me to say that I have 1, 2, 3. I will be converting them into 1, 2, and 3. I will be converting them into numbers, and then you can notice that throughout my data set, wherever I have these values, it will be populating as 1, 2, and 3 respectively. And also, they will be converted into a column, and this column would be having something like this. And you can see wherever you have a value of 1, that place would be a yes. Now, if we can logically assume that we are dropping this column, the information is still retained. That is, I can understand that if it is 0 on 1 and 0 on 2, then it has to be 1 on 3. If I have 1 here, then there is no requirement of 1 anywhere else. Likewise for 2. So guys, we'll keep things very simple. So here, as you can see, you have 2 columns, okay, each with a column of, each with a number of zeros and ones. And all these kind of conversions are very, very important for us to understand, because these are the things that we will be working on. Right, guys? So let us go forward and let us take this further and understand. Alright. So okay, so now here we have the next method, or the next topic of our discussion, that is supervised learning and unsupervised learning. Right? So the first one is unsupervised. When we talk about unsupervised, we know that in unsupervised we have not just clustering, but we also have time series analysis. Alright, and we have clustering. Now when we talk about clustering, we have k-means clustering here, okay, and then when we talk about supervised, we have classification and regression. Now here it is very important for us to understand the difference between what is supervised and unsupervised learning, okay. Now when we talk about each of these, supervised, as you can understand, the name itself says it is happening because there is a data which is learning, right? When you're talking about unsupervised, there is no learning process that is happening behind. Now let us just list out a few supervised learning algorithms that we have, or that we have come across, or that we would be coming across throughout the course. As you can see here, you have classification and regression. So different classification methods that we have are logistic regression. We have decision trees. We have random forest. We have KNN. We have SVM. We have Naive Bayes. So we have all these variants in classification. And when you talk about regression, you have linear regression and polynomial regression when you talk about at a very basic level. Now all these which we're talking about, we're talking only keeping machine learning techniques in mind, guys. There are still a lot of other techniques, and even there are some advanced machine learning techniques. There are deep learning techniques that we might want to see, and that we might want to learn. Alright, so now let us just understand what is the difference between supervised learning and unsupervised learning. Alright, so when you talk about unsupervised learning, here we have a couple of things which are important for us to understand, and the couple of things which we need to understand are, firstly, in supervised or either in unsupervised, the prime difference is here we split the data. Okay, when we talk about supervised, we split the data. Here you can understand this as train and test. we generally split, or we keep the data into train by 70%, and we keep the data into test by 30. Now in supervised learning, what generally happens is, you apply the machine learning algorithm onto your train, wherein your system or your code is learning from this information, and this information would then be tested on your test to see how accurately is your model performing. Now this accuracy is what is most this accuracy which you get here is of the prime importance when you're talking of machine learning algorithm. Okay, so it's of prime importance. Now what happens, or what we should ideally be doing, is we should be ensuring that you have highest accuracy or better accuracy, and this is not something which we see in unsupervised model. Now whenever you're working on unsupervised model, here you have unlabeled data. Now, when you're talking about unsupervised learning, or when we're talking about unlabeled information, right? It becomes very important for us to understand that unlabeled information does not have any kind of training or testing sequence that happens. Now here let us assume that you have two fruits. The first one is apple, and or probably orange, you can consider your favorite fruit here, and the second one is a banana. Alright, now when you're talking about each of these fruits of a banana, you will notice that this is a circle, alright, and this probably has certain length and has certain breadth and certain height attached to it. Now when you are feeding this data to your system would learn everything at random. Now let us say these are the two fruits that you have in your data set, but then you are suddenly introducing a third fruit, probably which is triangle in shape. Alright, now in this case you would see that this fruit also would be learned, and your system would try to identify, or your system would try to push this information into the closest possible side. Now let us assume that you have two shapes. Let us just consider a small case study here. I have a square, and probably I have another one which is close to a rhombus. Please don't mind the shape. Now here, if I come up with something called a triangle, then because triangle is not a part of your data set, your system would try to push this into the best possible side, and this is on the basis of similarity. Alright, now this is what clustering does, and in order to use clustering, you have something called as k-means algorithm. Now, notwithstanding clustering, the next one we have is time series algorithm, right? This is time series mechanism or algorithm. However, in time series algorithm, there are certain features which your system would try to identify. The first one being trend, the second one being pattern, the third one being cyclic trends, or seasonality, or things like these are tried to be understood from your data set. Alright, and once these are understood, you would as soon as you work on time series algorithm or time series mechanism, you would notice that all these factors which you have, they would come up to give you a futuristic value based on the dates that you entered. Now let us assume that I have entered values for the year 1990 to 2020. All right. Now this is almost good 30-year information. Now, when I enter this sort of an information, my system would find it very easy. Okay, I wouldn't say very easy, but yes, my system would now be able to give me an information which is futuristic. Now, if this is the trend till 2020, so till 2020, it would now populate the values for 2020 to 2030. Now, this is an example of unsupervised learning. Alright. Now, even when you're working on unsupervised learning or supervised, it could be this or this. Data cleaning is very essential. Alright. Now, here when you talk about data cleaning, even in time series algorithm, you might want to, you might generally have a data set which is not stationary, and you have to ensure that your data set is converted to a stationary mechanism and to a stationary variant. And this method of a non-stationary and stationary conversion is also part and parcel of data cleaning. All right. Now, talking about now that we have understood what are the different supervised, unsupervised algorithms, wherein the first one was k-means, and the second one was, or the second one is time series analysis. Now, let us go ahead and work or understand on the different supervised learning or supervised classification algorithms. All right. So here the different supervised algorithms are, as you can see, the first one is logistic regression. Now in logistic regression, your data would be classified into a yes or no. Right. This is the first variant. The second variant that we have is decision trees. In decision trees, you would be having a split of your data set. And the third one that you would be having is random forest. Random forest is basically multiple decision trees. Alright. Now, when you talk about random forest here, you would be noticing that within one bag you would be having a series of decision trees, and these decision trees that are almost thousands in numbers, and that is the reason why random forest is also called to be a very powerful algorithm, or a very one of the most widely used classification algorithm. But still, they also do not go away without disadvantages. And then the next one after decision trees and random forest is KNN, wherein we use or wherein we have the abbreviation to be K nearest neighbor. And when we're using this algorithm k nearest neighbor, your data set or your algorithm would generally try to identify the side, or it would try to classify a data point on one of the sides based on the distance, or based on the number of neighbors it has. So now let us assume I have two neighbors in pink, and probably I have three neighbors in yellow, and if I have my data point here, then it would get classified into the yellow side only, because yellow is majority. Alright, so that is what we have for KNN. Then the next one we have is SVM. SVM, we all know SVM is support vector machine, and this uses the concept of a hyperplane. Alright, and here let us assume that I have a couple of data points like this. Okay, let us just consider a simple example for now. This is SVM, and here I would be considering two classes or two features. This is my first feature, and this is my second feature. Now SVM uses the concept of a hyperplane. Now this is a hyperplane, and hyperplane generally comes up with the best division, or it comes up with the best split between the two variants or between the two classes. Alright, this is what happens when we talk about SVM. And also SVM has different kernel methods which we use. And guys, why I have been talking about all of these for a while is, even when you work on such complex models which are linear, or which are machine learning, or it could be regression, or it could be classification, or it could be clustering, the first thing is data cleaning is a mandate. Alright, and the second thing is, you would have different methods to apply, or you would be having a different procedure to follow if it is a supervised learning algorithm and if it is an unsupervised algorithm. Both of them do not have the same method. Alright, so yeah, this is the difference between supervised and unsupervised. And as we have already understood, there are different algorithms, or there are different vectors, there are different lot of other methods that we have available yet in clustering and classification and regression. For example, we still have something called as XGBoost. We have which is a variant of gradient boosting. We still have NLP. Alright, we have something called as market basket analysis. Market basket analysis is also very famously referred to as a priori algorithm. And guys, let me repeat myself and also request to you that if you have any queries, I'm sure by now you know where to reach out to us. You have the comment section right below you. Please hit that tab. So it could be any query, it could be technical, or it could be theoretical in nature, or it could be something related to your career. It could be something which is not related to the code. Whatever it is, please feel free to post it in the comment section below, and me or my team, we will be getting back to you at the earliest, and that is an assurance. Alright, so we have MBA, which is market basket analysis, and this is called as also a priori algorithm, or association rules are generally what we get when we work on a priori algorithm. So a priori algorithm would give rise to association rules, and based on this association rules, you will be able to come up with an analysis of your market basket, which is your data set of transactions that you have within a day, which generally happen within huge shopping complexes, or within malls, or within any shop. Alright, so these are the different supervised and unsupervised learning mechanisms we have, and this is how they are different when you work on them from data scientist or from a developer's perspective. Alright, so guys, I hope you have understood in this session what is data cleaning and why is it important, and also what are the different methods to do it. And now when we talk about data cleaning, we've covered 4 very important things, like how to handle missing values, right? What is imputation? We already covered a complete session on imputation, and that is just one session previous to this. You could just go back to that video and check what are the different imputation methods we have. Alright, how to handle missing values is also something that we have checked. We have seen how to remove columns and how to add columns. Alright, so we have covered all of these as a part of data cleaning. We have seen what is standardization. We have seen what is normalization. Alright, we've seen what is data visualization, and we've seen how to handle heat maps, which is a very important step for you to work on data cleaning. Alright, so we have covered what is data cleaning, we have understood why is it important and methods to do it, and thereby we've also covered what is supervised and unsupervised learning. Alright, so these are the different topics that we have covered, and I've already repeated myself. If you have any queries, guys, please reach out to us at the earliest. And if in case you find this video has been of any use to you, then please hit the like button, which is right below you, because that would encourage us to make more videos. And do not forget to subscribe to our page, followed by the bell icon, because when you do so, you will be having access to a plethora of videos to access from our library. And also, when you hit the bell icon, you will be notified whenever we come up with a video, or whenever we would be coming up with a release. You will be notified about it the moment we are up. So thanks a lot for your patience. Thanks a lot for being there. This is me, Varun, your trainer, signing off, wishing you all the best, and hoping to see you very shortly in the next video. Thank you and have a great day.